So this is Welcome to the How Did We Get Here, episode 7.
Sure.
7. Is the universe real or not? And if so, what implications does it have for humanity? Travis.
So oh man, I really wanted that one.
Man, I'm on the fence. I'm 50-50. But Thomas, I'll give it to you.
So it has, if it's real, then that's great. The impact on humanity is huge. If it's not real, there's no impact on humanity because humanity doesn't exist, right?
No, well, I mean,
If it's
the
a
brass tacks
simulation,
would be right. Right. If it is a simulation and everything within it simulated, including us, that
like
means we're
turning-
not real. But that doesn't really mean that we have no feeling about that. I mean,
No.
because our perception is what constructs our reality anyway.
or are you saying our perception is creating
I didn't
This
say
simulation.
that, but many philosophers have said that.
right?
that
Like
our-
Bostrom.
that-
Nick Bostrom, I think, kind of said something to close those lines.
says that the universe is just
Maybe I prepped.
is just a
Look at me like that.
congealment of our perceptions.
Right? Yeah.
Everybody's prepped but me.
Everybody's what?
Prepped.
Oh, for the discussion.
Yeah.
Well, you've lived your life, right?
Yes.
Well, you think it's
No.
real or not?
Well, you know what's funny is if you go back and you say, there's people that might think, well, what the hell are we talking about? But the idea that we live in a simulation, to me, goes back to The Matrix, the movie. And it's the first time that I ever stopped and said, you know what? This is a crock of shit. Nobody lives in a simulation. And then I thought, well, do I take the red pill? Or do I take the blue pill?
Come on, Copper Top. What do you think?
I don't have any hair, Thomas. How
No,
can
no,
you
no.
call me Copper Top?
Copper top, because in the Matrix, what we are batteries, basically.
Oh, Jesus, I was so far behind that curve.
That's okay.
I'm just the dumb
I'm
one.
here to help him out.
I'm the dumb one here. I'm not even going to say anything
It's
else.
like we're running a race.
Just go
Scott,
right
here's
up.
the
Copper
baton.
Top.
Here's the baton,
Oh,
Scott.
Jesus
Well,
Christ.
I see because in the movie The Matrix, right? There's an aspect.
That was really good, Thomas.
That's
Copper
not
Top.
me. It's a line from The Matrix.
It's a line from The Matrix.
Oh, is it?
Yeah. Have you ever seen the movie?
No, but
He's seen it probably 73 times.
I was inebriated.
Every time.
So
No,
now
not every
I
time.
guess we're watching The Matrix at the end of this episode, so I can show you the Copper Top line.
Yeah.
I remember the Copper
People
Top
remember
line.
it by the time it's over.
Yeah,
Okay.
I remember it now.
No. In the Matrix.
But while we're there,
Okay.
you've got a nice tan going on, Copper Top.
Oh, I do have it.
No, I mean you're Copper Top up there, man. Yeah, look at you. That's what you get when you work outside naked all the time. No hat. I love it.
When you live in the boondocks, you can do that, I suppose.
Well, that's not the Boondocks. My construction work buddies, they don't like it too much, but what are you going to do?
You have construction work buddies that work alongside you, Newt?
Right in the middle of town. Right in the middle of town.
I'm the only one.
Okay. Everyone else is closed, but you're just Newt. Okay. I guess.
Go on with your thing.
All right. What I was saying is, what the Matrix has an aspect of basically that it corresponds or correlates to what we're talking about, and that is in the Matrix. There's the people that were living within a simulated reality, which was originally Keanu Reeves' character and everyone else that he dealt with, and then
Which one is Keanu Reeves?
he's Neo?
I must have missed him in that movie.
Yeah, Neo. He was in the movie. Okay.
I missed the Copper Top comment, but that's okay.
How that differs from basically what we're talking about, though, is in the Matrix movie, there was a simulated aspect, but then there was a reality aspect. The reality, actually, when they took the red pill, they saw what the world really was.
Well, it was horrific.
Yeah, exactly. What we're talking about here, though, is everything. There is no non-simulated part. That's what. In other words,
Not that we know of.
we don't know that, right? We're assuming, for sake of this discussion, that nothing is real and everything's simulated, right? Mm-hmm. Okay, so that would differ, but I mean it does correlate in some way, but it also differs in a very important aspect, that is that nothing's real.
Right.
That's what we're talking about. Speaking of that, consciousness, today's modern schools of thought in the highest levels of philosophy and is that the universe is constructed by our consciousness, and that goes way back to. I mean, it goes all back to Plato and the
it does.
cave. You know,
Right.
but he was saying basically that we're all just tied up inside a cave, looking at shadows on a wall and perceiving that to be our reality.
Exactly.
Yeah. It's only if one of us is able to escape outside the cave, break our bonds, and go outside the cave and see the world for what it really is, and then we would have difficulty coming back and convincing everyone else that it's not what they see because that's all their experience. They wouldn't believe us.
That's Plato.
That's Plato.
I wonder if there's any like correlation between that and someone understanding that theory and then writing the storyline for the Matrix.
You know what blows my mind, Thomas? Is
Yeah,
that was
probably.
Plato
Probably.
contemplating that
Centuries
So
ago.
long ago.
2,000 years
Yeah.
ago.
Yeah.
2100,
See, I thought about exactly
Well-
the same thing. And where have we advanced ourselves from that guy was able to put those thoughts out that many years? We haven't really gone. I mean, sure, Plato didn't have a computer. That's fine. We've got a computer, but as far as breaking down the thought processes of humans, he was more advanced than most of us still are.
That's very true.
You know, and okay, for instance, mathematical functions. We all know, Pythagoras. They figured that shit out years ago, and we use the Pythagorean function in geometry and
Love it.
And speaking of Pythagoras, he had a school, and the people that studied after him they were called the Pythagoreans, right?
Right.
He created a school, and if you were an adherent or a disciple of his studies in his time, you couldn't eat meat. I mean, there was it was more than just
Really?
mathematics.
I had no idea.
It was an entire philosophy of life. Yes.
Wow.
They were what they thought were some of the very first vegetarians.
Wow. As much as I like math, I would have said no thank you.
Well, I'm just saying, and because
Because bacon is good.
Bacon is the way to roll every time. Bacon
and
or asparagus.
because of that,
Bacon.
they don't really know if Pythagoras came up with the Pythagorean theorem or if it was one of his students.
Okay.
That's been lost to time, but they accredit it to his school.
Okay.
So that's why it's. Anyway, what I'm saying is,
Regardless, he gets
yeah,
credit.
where the hell what have we done? That's my point.
We invented the iPhone.
I mean, it exists supposedly. Maybe it doesn't exist.
Maybe
but,
it doesn't.
I
mean, there's no proof of anything.
no, other than our perception.
Other than our perception, right? I mean, essentially, just beyond my perception, there's only you guys. There's nothing else right now.
That's right.
Yeah.
This room.
I only think my wife is where she was when I left the house, right?
That's right.
And everything as I'm going down the road, it's just as I remembered as a kid. I think trees should have grown by now. I think houses should have been constructed by now.
Sure.
Stuff should be dilapidated by now. The road should be repaired, made. Potholes should be there, should not be there. All that is just as I'm driving by. It's only me and my world.
You know what blows me?
And it's only you and your world. And you're imagining me saying this right now.
That's
exactly right,
yes.
Thomas. And everybody's experience in the world is unique unto themselves.
Absolutely.
Right. Absolutely.
Yeah.
Okay.
100%.
Here's another curveball. Everything that you think that you perceive as memories maybe didn't exist up till this very moment in time right now. All that shit could have been implanted. We could have started.
Download now.
Exactly. In other words, our entire
Or upload.
Our entire existence could have just been initiated in this nanosecond. And all the memories are just as fake to us as everything that we see around us at the moment.
Right, because the code was just written. They're like, finally, this code is written. It's ready for this.
Exactly. And we can actually have this discussion and come outside the realm of religion because it's like, and I understand. I completely understand people who are devout. We don't make any kind of light of that at all, religious thoughts. But what we do say is that's just another aspect. It could be another aspect of the simulation, if someone really stops to think, they go outside and they see a tree, they get in the car and they drive to work and they pay their bills, that's fine. But they don't ever stop and wonder, is this shit real? And it's not a foolish thought to think whether or not it is.
I don't think it's a foolish thought at all because I've considered it myself. Even years ago, I've thought about it.
Sure, well, Plato.
Right.
And we're talking 2,000 years ago. 4,000 years ago. Yeah.
Well, it's easy to stop and say, well, I thought of it because, I'm smart. But the reality is, maybe I thought of it because smarter people than me introduced me to the idea.
Sure.
Or
It's,
the aspect that maybe
as for me, in other words, this
I'm
is not a
not
concept. Right. I didn't just lay on the couch and watching my television show and decided, wait a minute, this may not be real. No, of course it's stuff I've read. You know,
Right.
it's made me think about this. Right.
And in a way, God, I'm probably gonna sound like a moron. Intelligence is only kind of relative to what we perceive and what we know.
And it's relative to the people around you.
it's
Yeah.
to what you're capable
to
of.
what you're capable of,
Yeah.
right? So in the grand scheme of things, I mean, you could be the smartest person on the planet and still be relatively dumb in the universe if it's real, in comparative to
Or for any other being
Of
that
what-
might be simulated within
right.
the universe.
Well, yeah. I guess I'm trying to say there is so much about the universe we don't know.
Yeah.
We only know about basically what we know on the planet, what we can look out and see.
Well,
So there's so much we don't know. So our intelligence is relative to our existence right here and what we can perceive.
It was either Aristotle or Plato. I think it was Aristotle that said, the only thing I do know is that I don't know anything.
There, exactly.
You know,
That's a lot easier than
that's
what
a-
I said.
And that's a philosophical argument. That's not really, whether or not the universe is real kind of thing, but it does pertain to it, and I understand that.
It's pretty accurate too.
Well, I mean,
Right.
it's a very accurate thought. Because that's,
Well, I mean,
that's
we're
the,
limited.
that's the beginning of knowledge. You
Yeah.
can't learn anything unless you admit you don't know something.
Right.
Right.
Wow.
Right.
I didn't know the copper top comment,
You probably just forgot
so I
that.
started off on the wrong foot.
That's
Oh,
okay.
which foot
That's
were you
that's
on?
Oh, the left foot.
on his
That
middle foot.
explains a lot.
Okay. Well, okay. Speaking of the universe and whether it's real or not, I was just listening today to another theory, and it's been around for a couple of years, but I had just heard esoteric bits of knowledge about it. I didn't really know much about it, but I'm not getting the name exactly right. It's called the inflationary. Now we've all heard that the universe. Yes.
Esoteric one time. Write that down.
All right, good deal.
Okay. In other words, we all know, anyone who's familiar with the Big Bang Theory knows that supposedly the universe was created from an infinitely dense and hot singularity, right?
Yeah.
And it
Yes.
exploded. Well, and then the very first microseconds, milliseconds, femtoseconds,
an expanse happened.
minuscule amounts of time, it doubled, quadrupled, quintupled. It geometrically expanded its size. It expanded faster
I
than
don't
the
know
speed
that
of
you
light.
can allocate a period of time to it because supposedly time didn't exist during that time.
It did at the moment it exploded.
Oh, well,
time
no,
began.
right.
Yeah.
Okay.
Time
Prior
but
to
not,
that, no.
not prior to that,
Yeah.
according to the Big Bang Theory. Right, you're right. Time supposedly did not exist for us in this universe until after the Big
Until
Bang
it
was
began.
issued. Yeah, that's right. So that's why once it did explode, if it exploded, that's why the universe got so large,
And it did.
and it expanded into such a great space that was faster than the speed of light because. According to Einstein, nothing within our space-time fabric can go faster than the speed of light. However, when that was happening, space-time itself was actually expanding as well.
Right.
So that's why it didn't break that rule.
Well,
Okay.
that might be one of the elements of how would you say it? A limitation on our existence in terms of
Our
a
understanding.
simulated universe.
Our limited
If-
understanding.
Well, no, not our limited understanding. If we're limited to the speed of time
Right.
Speed of light.
or the speed of light.
Right.
Yeah, I'm sorry.
That's okay. I knew what you meant. In what way? What are you talking about? Being limited to the speed
Well,
of
I
light?
mean, that would keep us off this planet, or keep
Let's
us
keep
from
us
going
on
off this
Get
planet.
on this planet. Well, we can go off the planet. We don't have to be faster than the speed of light to go off.
We're not going to reach anything of significance unless we can.
But we don't have to. We can beat time with our current rocket ships that we've got. We just have to. In other words, to go into the future, all we have to do is go really, really, really fast. Now we
Get
can't.
further away from our Earth's gravity.
No, we don't have to go. Now, okay. I'm glad you mentioned gravity.
You're welcome.
Okay, but it doesn't necessarily have to be away from the Earth's gravity. There's two things that make you be able to travel into the future by going fast. And when I say going fast, you want to go to some percentage of the speed of light. But we could create solar cells now. We have the technology, although we haven't created them. We could create ships now using gigantic solar sails that would catch the solar wind and that would be a constant acceleration for this craft, right? In other words, as long as the sail is pointed toward a star, right? All right, and it would go and it keep pushing and keep pushing. And so since you have no drag coefficient because there's not space, you don't have any
Right.
drag when you're outside of gravity.
Of course.
You just
outside the atmosphere
You have
also.
right. You have constant acceleration. So in other words, it's like having your foot on the accelerator constantly. You're not going to go any
Nothing's slowing
slower.
you down.
And how long would it take us to reach the nearest star doing that?
Oh, well, it'd be. Well, it depends. Again, how big the sail is and how much thrust that we're getting and so forth. Well, many years, many years. But but that doesn't matter.
Hundreds of years.
Yeah, well, not necessarily. Not necessarily. Again, it depends on the size of the sail. But what I'm getting, it doesn't matter. That's a moot point. What I'm saying is, we can travel to the future if we get in this craft and we start heading away from the sun, right? And we go, and if we change direction and come back. Now, if we kept going, here's the cool thing: if we're on board, if you have a twin, and you're on board the spaceship and your twin stays on Earth, and
Day one. You're minutes old.
right, and you keep going away. As long as you don't ever change direction, as long as you don't change direction, you guys are the same age, always.
Okay.
It's only when you turn around and come back that the age starts, that they become old and you stay this current age. That's a weird way to think about it. And the math is extremely complex, and I don't even understand it.
No,
But,
it's pretty easy.
No,
No,
Think
but I've
about it.
looked at it too.
Okay.
But I'm saying if you're living in a simulation, that's
Yes.
a really good restrictant to going anywhere because the speed of light prohibits it.
So you're saying that,
Oh.
in other words,
It's a fail-safe in the simulation.
It's a fail-safe in the simulation because I'm not going to get anywhere if I can't exceed the speed of light.
I got you. Yeah.
I'm not going anywhere, Thomas. I'm just not.
well, why would the people or why would the entities who created a simulation care whether or not you're traveling away from a simulated point to another
Well, it's
simulated
just like a
point?
computer, Scott. If I look at the stars
Mm-hmm.
out there, they don't exist. But if
Until we observe
but
them.
Until I enter them.
okay.
If I enter them, then the computer has to reboot and upload
And it's
a whole
got-
lot of information.
I've got to render.
It has to
it's gotta-
procedurally render what you're perceiving if you go out there.
Yeah, because it's just lights until I get there.
Yeah, that's right. But then again, if it's all a big simulation, because when you leave here, it doesn't have to render here anymore. So
That's right.
Yeah. So there's, in other words,
That's a good point.
It's a zero-sum game. You see what I'm
Oh.
saying? Why
I,
does it-
I hope it renders Rachel when I get home. I miss her already.
What I'm saying is, I don't see travel as a restriction because when you take your perception with you when you go, it doesn't take any more computer horsepower to render what you see here than what you see there. Do you see what I'm saying?
So do you think it's not a simulation?
No, I think it is. I mean, what do I know?
Oh, you're
I'm-
stepping out.
No, I think it
Stepping
is.
out.
I think it is a simulation. That's exactly what I'm saying.
All right, I'm with you.
Okay. And what I'm doing, and what I want you guys to do is throw
Challenge.
challenge curveballs, and then let's see how well an assumption stands up. That assumption was a good one, but it just didn't stand. In other words, there's no logic that would keep that from happening.
Oh,
in
it's
other words,
just not smart enough to.
No.
it ain't getting.
there are no dumb assumptions, and I don't mean that at all. What I meant was, I get your point why you said that, but then you probably just weren't thinking, okay, it doesn't need to render that if I can't get there, and I get that. That's true, but it does. If you do get there, it doesn't have to render here anymore for you. Do you see what I'm
Maybe-
saying?
So this is your
maybe
world
the
according to you.
simulation-
Well, sorry.
This is your render according to you.
The simulation's
Can
not.
I have a tack, please?
The simulation's not prepared.
Attack.
I'm just going to see if you
Oh,
can.
thank you very much.
Simulation's not prepared to render something that they don't want us to go to. So the speed of light's a limitation.
I mean, it could be, obviously. It could be. I don't see it as one, but what do I know?
We ain't developed a warp drive.
No, we haven't. But I'd like to get back to where I was a second ago about
All right,
this
go ahead.
universe. All right, but thank you for that sidetrack. That's fine. That's no problem. Okay. Now the new theory, as I mentioned, the Big Bang, that's been known for a long time. The new theory is that the universe or the cosmos. I'm going to say the universe because the universe is what we perceive as our universe, right?
Yes.
As the distant galaxies and quasars and all that. I'm going to refer to that as our universe. The cosmos, I'm going to refer to the multiverse or everything that
Okay.
may be outside our universe, including our universe. Okay, I'm going to refer to that as the cosmos for the sake of this conversation.
Yes.
Okay. They think now with this inflationary, which is different than the inflation after the Big Bang, the inflationary theory of the universe or the expansionary inflationary. I don't remember exactly what it's called, but you guys can Google it. They think that the universe is in a constant state, the cosmos is in a constant state of expansion, and as it gets too far, that waveform, the quantum waveform, they think the entire cosmos is a quantum wave, and they think as it gets okay, and they're perceiving that as a as a hill on a graph. Okay, if you take a piece of graph paper and you have a hill that goes down like this and it curves like a parabola.
It's called
like
a bell curve.
Well, right. It would be similar to a bell curve,
Okay.
yes. Okay, but if the top of that hill, the plateau of that hill is relatively flat, doesn't have to be completely flat, but it's relatively flat, you have nothing but energy and expansion. It goes and goes and goes. It's when the energy tapers off and goes down to these valleys that the waveform collapses, and all that energy, it takes gargantuan amounts of energy to maintain that waveform that is the expansionary universe. Okay, it's when that collapses, universes are spawned off. And in other words, when it doesn't have enough energy in the waveform to maintain that plateau, and it falls off to these valleys, the energy drops, and that's what happens when you convert energy to matter.
You convert energy to matter?
Well, first, let me put it easier. What happens when you convert matter to energy? You have E equals MC squared, right? You get atomic bombs and things.
I was going to say nobody's done energy to matter.
Yeah. Well, actually, yes, they have. In very minute quantities inside the super colliders, they have created particles out of wave functions.
I eat my
Okay.
words.
Okay, that's okay.
You're right.
Okay.
But not on a grand scale.
Absolutely, and that's a good thing.
Are we
Okay.
the grand scale?
Well, let me get back to what I was saying. Okay, so when this energy falls off, tremendous amount of energy, by the way, and it falls off.
He's just blown my mind.
I know, that was nice.
Well, when it falls down to these valleys, we're still talking a buku amount. We're talking so
Right.
much energy, it creates a big bang.
Right.
Okay, so even a little chunk of that plateau energy trails off to either side of this, a new universe is formed. And they think that there are infinite amounts of bubble universes, just like ours, or different. That are different than ours, that are being created constantly, all the time.
Yes, I can see that.
Okay.
And for
And-
such a long time.
Well, forever.
Forever.
If they think that's the constant state. Not only that, or every single one of these bubble universes are always going to be permanently isolated from every other, because the amount of expansion that when one pops off and the energy wave continues to go is geometrically expanding that much larger.
Okay.
So you will never ever see another universe.
Right.
Well, one thing about it.
What's that?
This is nothing but theory.
It's substantiated by some experiments, but we're
But I
talking
mean, but
theoretical
we don't have-
cosmology.
We don't have any way to prove any of that.
No, all we have is our study of quantum mechanics, which supports most of this. Okay, let me put this. You're right. This is more than theory, because there's been lots of theories, like people like, the universe was created out of the nose of the great green aqua sneezer. Okay, that's a Douglas Adams quote for you guys. But in order for a theory to supplant the most important and most common theory, which is right now the Big Bang Theory, it has to explain things the Big Bang Theory cannot explain. It has to, because the Big Bang Theory has been supported by evidence. We can look up the stars and we can watch Einstein's curvature of space-time and all these things. And if you can take physics and say, because I know if I drop this rock onto this glass, if I had a rock, I know that gravity from the Earth is going to pull the rock toward it, and most likely it's going to shatter the glass. That's
At
called
least make a noise.
That's called a deterministic universe. In other words, I've got something here, and I know probably what's going to happen if I do a certain action. The Big Bang creates a deterministic universe. In other words, it gives us things that we can predict, right? Like orbits of the planets, stars exploding, so forth. People running into trees. But in order for a theory to supplant
One time, and you keep bringing it up.
in order for another theory to supplant that and become even more supported, it has to do everything that the Big Bang does and do some things it doesn't do. This new theory of expansionary inflation does that. It does it at the quantum level, quantum mechanics, which unfortunately I'm not well versed enough in to explain to why, but I have listened to it and I have looked into it.
Who's the guy that's come up with those ideas?
Many, is physicists and quantum mechanic theorists right now, and astrophysicists working with these guys. And like I said, you can Google it. And but just trust me, that's the new theory now. And according to these guys, and according to what I learned, it has a very good chance of supplanting the Big Bang as being the most probabilistic theory of the universe or universes.
Yeah.
I know what you were trying to say.
But that doesn't mean that doesn't mean it's real. Or
No,
not.
but it still doesn't get us to where did that come from?
No. Yeah, no, or even if it really
Or if
exists.
it really
because
exists,
they don't
right.
debate whether or not that exists. In other words,
It's a possibility. is
They've
what they're
came
saying.
up with this theory based on what quantum mechanics is
Right.
teaching them.
You know what? You know what gets me about quantum mechanics is the breakdown of it at the essential fundamental level. You know,
The real small, minute.
well, I mean, when you're talking about the smallest particles and stuff like that.
Okay, yeah,
you know,
because when you say breakdown, the theory doesn't break down. You're talking
No.
about space.
the understanding of it breaks down.
Well,
How's it coming
Well,
into view?
the people,
Where did it go?
The people who study quantum mechanics, they will tell you they're the first. They don't understand it. They don't understand why it is the way it is, but they can make predictions that almost are exactly true. Now, I think it was Feynman, Richard Feynman, a physicist, said that he said that if you think you understand quantum mechanics, then you don't know quantum mechanics. And he's one of the godfathers of quantum mechanics. But God, I'm not obviously that, but they understand based on their knowledge of quantum mechanics how things at certain levels will behave. But what you're talking about, I think, Travis, is you're talking about if we examine our universe, our reality at the smallest level, like the Planck space,
Planck.
Max Planck, Planck
Planck
like,
space.
I think it's Planck. But anyway, he's a physicist, was a physicist.
Planck,
Planck.
Max Planck.
Planck.
Tomato.
Planck, Planck,
Uh,
Planck.
But what that is, guys, the Planck space is the smallest conceivable volume that you could have. It's subatomic. It's smaller than quark.
It's little bitty.
Yes.
It's way down there.
What we've shown, that what quantum mechanics has shown us, is if we have a space, it's a complete vacuum of a space that's that small, that reality pops in and out of existence.
It should not.
Energy and particles pop in and out of existence within that space.
That's where the wormholes come in.
That's where the computer's going.
very
Don't
small
look here. We
fundamental
haven't
levels."
figured this out yet.
Yeah.
Yeah.
We've
The
never
simulation
we've
is-
never discovered big wormholes. It's always the little microscopic.
Yeah. The
That
simulation
plays
is,
into actually our discussion that we're talking about. If, indeed, we take our reality, because, for instance, these microphones, us, you, Travis, that feels solid to us. It feels solid, but there's
it probably feels really solid because I'm a beast. It's ridiculous sometimes. Do it again.
That's your fourth shirt you've had to put on. So you sneezed and tore the other one to pieces.
Whoops.
Okay. What I'm saying is there's more empty space in you than there are solid.
Oh, I know.
I guarantee it,
the
especially in his head.
Between
Yeah.
the years?
Yeah. Yeah. I mean, the fact that one day they could just pass right through each other.
Yes.
Because of all the empty space, they're just going to line up one day. It's just going to
That's
pass.
exactly right.
It's ridiculous.
In fact, did you know that if you did this enough, that your finger actually would go through the other finger? It's called quantum tunneling. In other words, that's why we have sunlight. The photons that are generated from the nuclear fusion in the sun would never make it out if they couldn't go through what is perceived to be solid matter coming
sure,
out.
right.
And so very, very, very few of them were able to. I mean, we're talking 1/quadrillionth of the amount that's generated actually makes it out. But thank God it's enough for us.
Absolutely.
But of course, we would die before this
Right.
ever happened.
Of course.
But if we could do it infinitely, it would at some point it would go through that. Isn't it crazy to think that? And quantum tunneling allows that to happen.
You're welcome.
Yeah. Okay. Well, getting back, you're just like nerd. I'm sorry.
I did know that, by the way.
Okay.
I wasn't aware it was called quantum tunneling.
Okay. That's what's called quantum tunneling.
I just know that one day I'm going to snap my fingers. I'm not going to hear anything and be like,
Because your finger's going to go.
"Son of a
through
gun!
your-
It just happened."
my knuckles
Did
quantum tunnel.
anybody see that? No.
Okay.
Travis said.
Please
Travis-
get me to a doctor.
Travis said, "Durr."
Please
Okay.
get me to a doctor. I think I
All
pulled my nose off.
Let's leave guessing out of this just for the moment, just for these guys. Let's leave all conjecture completely out. What we do know is that our universe, let's say for the sake of argument at this moment that it is real. We know that if we examine our universe at the Planck space, the tiniest space we can imagine, that we see reality pop in and out. That's not a conjecture. That's a known fact.
I know that.
Okay, and is that because now let's speculate a little bit now. Is that because we're not supposed to examine our reality at that small of a level? In other words, are we seeing?
I think so.
Are we examining the simulation too closely?
I think so.
See?
That's a great argument
Yeah.
for that right there.
Yes.
The simulation stops right here.
That's right.
Yeah.
In other words,
we never
have no-
thought you would get this far.
That's right. It's so,
But you're here.
But you're here. We got to rewrite.
And what happens when we do, and they notice that we're examining that?
It changes.
Beep.
You reboot. Is that what
Yeah,
you're saying?
reboot.
Okay, but I mean,
And then we're having a different conversation.
I mean,
right?
well,
We're here. We're
No.
having a different conversation. We're talking about Planck and how we can see all this, but now we've dug deeper into Planck space.
Yes.
And we can see all this other stuff. And
in the
son of
quantum
a-
phone bubbling
Right.
in and out of existence, you
Yeah.
know, and according to Newton's law, energy cannot be created or destroyed. The law of thermodynamics. You can't create energy or matter. Can't be
Yeah.
created or destroyed. You can transfer, transmute from one to the other using an atomic bomb and so forth, and nuclear fusion and so forth. But you cannot destroy it. Well, the Planck space shows us we can watch matter and energy being created.
right.
And it never stops. In other words, and that's a vacuum we're talking about, right? And it just pops in and out of this. I mean, physicists are puzzled. They just shake their head at that. They don't know what to think about that. And I understand that.
I think we are as limited to understanding on the great scale as we are the small scale.
I agree. I
Yeah.
completely agree.
Because
and really, is it any different?
I was going to say, in theory, they're probably both the same
Exactly.
because you always have to have something, right?
Yes.
There's always got to be something there. You can't have nothing there. There's got to be something deeper than Planck.
Well, we tried to have nothing in the Planck space, right? To have
Right.
and we see that we can't have nothing.
Right.
We can't have nothing. And it's not, and that's not a double negative. We try to have nothing, and we can't have nothing
Right.
because in nothing, something
Something
appears.
Now we just have to dig deeper, right?
Well, like
It's just like Travis's fantastic verbal jest that he had in Florida years ago.
okay.
When you're digging for gold, when you find a nugget,
Shut up about that one, by the way. No, go ahead. I'm just kidding.
do you stop digging? So that's a nugget, right? When you've got your Planck space and you're like, okay, there it is. Wait, what's that? That's a nugget. Don't dig anymore.
Dig it
Well,
go.
we're just going to quit.
We're just going to quit digging when we
Hell
find
no,
the
we
first
keep-
gold
we
nugget.
keep digging.
Somebody's got to keep digging.
Somebody's digging like crazy, Thomas.
Make Planck, in theory, the size of this Earth, and you dig deeper. Make that Planck space,
You know what's
in
funny?
theory, huge.
I've got,
and
I've
what
got,
is there?
I've got to say this, and I'm going to bring
Because
it up.
200 years ago,
Well, there's a reason that they can't go smaller than the Planck space because the Planck space was theorized as the smallest space imaginable. In other words, it's not an arbitrary thing. They made it the size that it is because, in reality, you can't have anything smaller. Now we know that there's infinite regression, and it doesn't matter how far you go; you can always go
Right.
halfway.
Or
Tur-
so we call
turtles all the way down.
are we calling
all the way
Planck the ultimate infinite regression then?
Well, I mean, we could use that as the bottom of infinite regression,
Okay,
which
so
theoretically you can't have.
You can have.
That's right.
So we keep digging for gold.
That's right. It's just at some point they have to say point A is as small as we can go. For instance, a singularity. They say
yeah.
like a Planck space would be a singularity space, right?
Yeah.
Infinitely small. Is if something is infinitely small, then you can't go smaller.
Okay.
Okay, and at that point we still see reality being
So
created.
if the thing that is so infinitely small has things coming into it,
no,
and
not
leaving,
No, not coming into it. Leaving.
popping up.
From within it. Within
So
it.
we're not small enough then.
Hey, well, I didn't write the book.
So whatever that is saying, hey,
The quantum vacuum.
we're here for the party.
At the smallest space imaginable, shit is coming from nothing.
Not the smallest space imaginable, the smallest space known. Right?
Well, it's not really known.
If we've seen it,
because
we've known.
No, we haven't seen it because it's smaller than an atom.
It's,
But I thought
it's
you
a
said-
theorized space.
the smallest
It's-
space we can think that
I
exists.
thought.
What they've used instruments to detect stuff being created. They've never seen it. You can't see it.
I mean, detection is the same as seeing.
Okay, in an essence, yes.
Right.
But just so you'll know, you cannot have anything smaller than the Planck space in our universe.
Okay.
Okay.
Obvi-
I understand.
obviously, we can.
No, you can.
If something's showing up inside of it in the Planck space,
It's
in
being-
theory, detected,
Yes. Yes.
something is smaller than that.
Well, they don't know because they just see it emanating from it. So
Right.
is it coming up because it's being created on the surface, within it? What we don't know. We don't know.
Something.
Yeah. Right. In other words, I don't have a. You can't measure on a yardstick. We're talking,
No.
we're talking tiny, Tommy.
You can't measure it.
Tiny, Tommy.
Itty bitty bitty.
You know
Okay.
what? You know what gets me is I got to go back to it.
Okay.
One of the things that's just perplexed me forever when it comes to a simulated universe. You talk about the double slit experiment,
Yeah, and that's a prime. That supports
and it's like
supports everything we said.
we've been doing this for over 100 years,
Mm-hmm.
and we watch it.
It's so frustrating.
We watch it, and it's two slits, and they act in a pattern that's not waveforming. But if we don't watch them, they're waveforming, and we can do it with electrons. We can do it with photons.
Mm-hmm.
They act the same,
Yep.
Have we ever tried with croutons?
and
We have tried with croutons. It just makes a mess.
Dang it.
We tried with
thought I was
Klingons
onto
too.
something.
There's a lot of blood.
Klingons, protons.
lot of
I mean, come on, man.
Okay, let me throw a curve to the. I watched a girl
All right.
on the internet. I think she's a physicist. She decided, okay, she did the double split experiment just as a home experiment, and she showed actually a unique way that you guys can actually try this at home. A laser pointer. Most everyone has a laser pointer at some point.
Craig did that in the car in
his trunk.
In his trunk.
He did
with
it. His
a,
slots are way too far apart.
Yeah, and his,
Come
and it has
on,
a flashlight.
Craig.
Yeah,
Come
yeah,
on.
okay.
I don't know.
What I'm saying is this: you take a small cardboard, a piece of cardboard, take one of your hairs, and tape it through a hole that you cut in the cardboard, right? All right, and then you have another piece of cardboard at a distance away from it. I'm about to cough. Hold on. Sorry, Tommy.
And we're back after the commercial.
Okay.
Nope, now we're back.
And
You good?
she had her hair taped to it, had a laser pointer, and then another piece of cardboard behind it. She turned the laser pointer on, and she looked, and because she didn't do a double slit experiment, she put the hair in the center of the beam. She wondered what kind of pattern that would create, and it absolutely created these little concentric arcs away from that. So it was like it showed the shadow of the hair in the middle.
Wave formation.
It showed wave formation around, right, and then the hair. Then she thought, I see this beam. She had a red laser pointer. She could see the red laser pointer going right to the left and the right of the initial hair, right? But she didn't see the beam that were creating the other arcs. But she knew the beam had to be there. That beam had to be there because it was creating the light on the cardboard. So she said, well, these beams have to be here, but I can't. Why do I see this beam and not see the others? Granted, the beam that was closest to the hair on left and right was the brightest. So
Yes.
it made sense that she might be able to perceive and see that beam and wouldn't be able to see those others. But she knew they had to be there. So she tried making her room darker so she could see it. Didn't help. Then she came up with the theory. She put a smoke machine in her
Ooh,
room.
nice.
She created a smoke machine, and the moment she did that, she saw all the other rays emanating from the split of the hair out to the other arc. So sure enough, she speculated that she'd see those, and they're all there. They're weaker. That's just why it was harder for her to see. Okay, now how does that differ from the double split experiment? Instead of being one stream of photons of light going through a double split, two slits, she split a single laser beam into multiple factions by a hair, and it was easier to see. Now, so then she put a photon detector past her hair at those multiple beams, and that was supposed to detect the photons coming. She turned the photon detectors on, and they all collapsed. They all went away. Now, mind you, these photon detectors aren't affecting the beam of light. Well, they're not shining anything into it. They're taking the light that's created from the beams, and they're detecting at their end, out of here. The simple process of her detecting those collapsed those waveforms that she was watching. Just like the double split experiment.
Yeah.
Yeah, but it's an inverse of that.
Well,
but it works both
she
ways.
just proved 100 years of theory.
She's right. And maybe someone else had done the hair experiment before. She's the only one I knew of. But it boggles the mind to think that the universe changes simply because we observe it. And it does.
Well, that's what I'm talking about. At the most fundamental level,
Sure.
if you really want to look at a simulated reality, it breaks down. It breaks down when we get to that level. And we've not, Einstein got as far as he did. And there's no doubt. That's a lot of great thought process to
Of
get where he
course.
was at. But once you get down past that,
Yeah, and he wasn't really deciding whether the universe was real or not. He was
No,
just,
he wasn't.
He was just trying to the properties of the
he was
universe.
just going, how far down can we go?
and how far out can we go?
Yeah, I mean, it's a country song. There's a flea on a hair on a frog on a wart on a log
In the bottom of the sea.
on the bottom of the sea. How far down can you cut it, and where does it end? You know?
And you know, Einstein used the last 20 to 30 years of his life trying to figure out the grand unified theory to tie physics in with quantum mechanics,
Absolutely.
and he never figured it out.
No.
You know, and you know, they said that we all want to think that the universe is deterministic. In other words, when we throw a rock, we want to hear the splash in the pond
Right.
because we're expecting it to happen. But that's what Einstein said about, you know, he doesn't believe that God rolls dice. Quantum mechanics, you know, is all based on probabilities.
Mm-hmm.
This might happen, or this could happen, but I can't tell you whether or not it will.
That's right.
Quantum mechanics tells you that. So in other words, how can you say you don't know? I mean, I'm not talking to us. We're a bunch of guys just throwing shit out. But how do these physicists that work these places like CERN and, you know, and the Large Hadron Collider, when they come out and tell you we don't know how the universe works, that should tell the rest of us something. That it's much, much stranger than we think. You know, and we're not
Absolutely.
we're not talking
It
about.
goes back to me saying how limited we are with our knowledge.
Oh, absolutely.
We have almost no idea what's going on.
Absolutely.
And with all the knowledge we do have,
Yes.
it's still minute.
Okay, do you, and I'm wondering if these guys know. Do you guys know what, for instance, a particle accelerator is for? Do you guys know what a particle accelerator is for? In other words, why do we need one, and why do they have to keep building them larger and larger? And this is not a test. I'm just curious.
I mean, I think they spin these photons around, and they crash them into each other to measure what comes off of them.
okay, but why?
Oh, to see what they're made up of, right?
They're
why?
trying to create a black hole.
Well, that's been theories, but that's
CERN
not what
is
they're trying
the
to do.
devil.
No, that's. I mean, people thought they could possibly do that, but that's not the purpose of why
trying to
they're doing
open a
I think
portal.
they were worried about I think they were worried about doing that when they started.
Yeah,
well,
there's going to be a portal.
it's-
They're going to destroy the
They
planet.
thought there was a possibility, just like the original, atomic bomb. People
They didn't know.
They didn't. Well, they didn't know if creating a nuclear fission reaction was going to start a chain reaction in the atmosphere.
And just spread over the entire world.
That's right. That was. I mean, believe it or not,
And
guys,
they did it anyway.
They did it
They
anyway.
did it anyway.
That was a possibility,
Right.
and you know, of course, they had lack of knowledge. Obviously, they knew that was a possibility. They didn't know if it was likely, but they knew it was a possibility, and they did it anyway. The people at Los Alamos, guys, and Oak Ridge, Tennessee, working on the Manhattan Project, knew there was a chance that they could destroy the world, igniting the first atomic bomb,
Chain
and they did
reaction.
it anyway. You know, okay. No, the whole purpose of a particle accelerator is to see how the universe was created. In other words, it creates higher and higher levels of energy when they smash those particles together, right? And the faster they go, the more energy that's created. Okay, the more energy that's created, you get more and more rudimentary particles. Okay, they're trying to see what the soup of the universe was made out of at the time of the Big Bang. Now, because I'm talking before protons, before neutrons, before photons, all this stuff, there was a soup of something, a high energy plasma. They're trying to get down. They're trying to create that. So once they get to that point, they say, okay, that's the point. That is the smallest. We can't. Or that's the most elementary particles. We can't do anymore. That's what the whole purpose is, and that's why
But I mean, you can always go. You can always dig deeper, right?
Well, not when you get to the point. Well, they can, and that's what they're trying to do. But they theorize that there is a final situation, and that's why they. Okay, different particles have different properties. Duh, everyone knows that, right? And they just found out a few years ago, like 10 or 12 years ago, the Higgs boson, right? It's a subparticle, and what the Higgs boson does is it is the elementary particle that assigns mass to any other particle. In other words, a proton and a neutron has weight, but they wouldn't have any weight or mass. Weight and mass is different. Weight is subjective because on Jupiter you weigh one thing, on Earth you weigh another thing, but mass is always the same.
Absolutely.
Okay, so when I say weight, I'm referring to mass. That's what I'm referring to. None of those particles have any mass whatsoever if they don't contain Higgs bosons. Okay, and that's what the Large Hadron Collider was built for, to try to detect it, because it was the next step down in elementary particles. Well, now they want to know what particle assigns gravity. So they're trying to find a graviton. So they're trying to build.
Oh, that's interesting.
That's right.
Love that.
Because they think that the graviton is even sub to the Higgs boson. So it may exist, it may not exist. The Higgs boson may not have existed, but they found out it did exist because every study that they did in all their mathematics said it should be there, but they still never witnessed it. But now they have.
So, apologies. So they're looking for gravitron.
Gravitons.
Gravitons.
Yeah, gravitons. If they exist.
If they
Yes.
exist.
Mhm.
So, is it possible to have a lot of mass and not have gravity?
Well, not according to everything that we've studied so far.
So far, right.
In other words,
So-
because we have just two particles. Let's say you've got the infinitely small, not
Right.
say infinitely small,
Really, really
very
small.
very small
Yeah.
mass. If you have space in a complete inside of Planck space,
Mm-hmm.
you can't do that because it wouldn't fit inside of Planck space. Let's just say a small space, okay? If you have one particle here and one particle there, and they're completely isolated from all gravity and elsewhere, those two particles will attract one another
Mm-hmm.
because the properties within them mass attracts, and they have a gravitational pull one to the other.
Right.
Okay.
So,
Well, the best we know, everything has a gravitational pull.
Right.
Based
Everything
on
that has
weight.
everything that has mass.
everything that has
Yes,
mass.
That's exactly right.
Well,
yes.
not weight, but mass.
That's right.
So,
exactly.
but is it my understanding you just said that we're trying to figure out what assigns
Gravity.
gravity?
Gravity.
What?
So it's not.
What? We're trying to find a particle that carries gravity as its purpose. Yes.
So mass doesn't have anything to do with gravity.
Well, no, because gravity is a property of mass.
Right.
You see
Now,
what I'm
I'll
saying?
understand
Jupiter has
that.
greater mass than Earth
Yeah.
does.
Yeah, it has more
It's-
gravity.
It's bigger.
Right, it has more gravity.
Right.
But why does why?
Oh,
does
I
Jupiter-
got you.
Okay.
Yeah, I got you. Yeah,
Okay.
It clicked.
In other words, Einstein said that gravity is not real, that what happens is when you have mass, leave gravity out of it. When you have mass, it warps space-time. And therefore,
Mm-hmm.
like the moon around the Earth and planets around the sun, because they're traveling, that mass is traveling along a curvature of space-time
Right.
caused by mass, not gravity, caused by mass. That's what causes it to go around and around in orbit. Like for instance, you could take a basketball, put it on a trampoline, a bowling ball, put a bowling ball in the middle of a
Mm-hmm.
round trampoline, and then roll a baseball around it. You'll see the baseball goes around in a circle. Eventually,
Yeah.
will fall back into
Clunk.
it. It will eventually. Okay, that's Einstein's. But now the new theories is that Einstein was right about many, many things. You can't dispute his genius, but he may not have the final solution of gravity. And they're thinking that space-time isn't really a thing anymore. It's great that, and it works, and it predicts all these things that we can observe. But just because something, for instance, if you stepped outside every morning and someone hit you in the face with a baseball, you would think that stepping outside caused the baseball to hit you in the face.
Exactly. It does. I don't know where it comes from.
Let's just say that you had an asshole neighbor who enjoyed pelting your face with baseballs. So
I'll get
your
it.
perception of reality would be that if you step outside that door, you're going to get pelted in the face with a
Every
baseball.
time.
But that's actually not a nature of the universe. That's just something acting within it.
Right.
Just like that, Einstein's mathematics, his tensor equations and so forth of gravity, of curvature of space-time, might fit a certain thing. They don't have to be right, but it fits a condition. You see what I'm saying?
I do.
Okay. And again, it makes him brilliant for even coming up with it, because who the fuck else would come up with that, right? It's just a brilliant batch. And Einstein did all his brilliant work, guys, when he was in his 20s.
Yeah.
20s. It's crazy.
And spent
What
the
have I
rest,
done?
Spent the rest of his life trying to figure out why he thought that in his 20s.
That's exactly right. You know, I'm nearly three times 20, and I've never ever came up with an equation like that, and I never will.
You know why?
I never will, Travis.
The
I will
program-
never come up with an equation
Well,
like
you
that.
spent the last 20 years trying to say that,
The program writer doesn't want you to know.
yeah, well, I don't know, maybe.
The simulator.
I spent my 3 times 20 wondering at these people that do have these genius.
Oh,
you
yeah.
know, and
You should have a Solway conference poster in here somewhere.
I said, well, what?
One of the posters from is it Solway or Solvay conference?
Oh yes, you're talking about where Madame
Yeah.
Curie and yes,
The old
Marie
If we
Curie.
go back to,
Yeah.
how does that fit into simulation?
How does what fit into simulation?
What you've been talking about. How does it fit into we're living in a simulation?
Well, okay. In one gigantic way, it fits into that. No matter how closely we examine, we still don't understand it, and we watch things being created out of nothing. So, if, in other words, it directly correlates with, like, for instance, a video game that you play. If you're driving in a race car in a video game and you see you kind of see the trees in the distance, and they look kind of blocky, but when they get close to you, they look really good. That's called procedural rendering, right? In other words, the game doesn't, and we mentioned this before, the game doesn't have to render what you don't see, but it has to render very good what you do see.
It's my stars.
That's exactly what you've been saying, yes. So that's how, Travis, that's exactly how it correlates. In other words, we shouldn't, if the universe is real, if it's real, guys, we shouldn't see things appear in and out of nothingness. It shouldn't happen. What we should see is, like Thomas said, eventually smaller and smaller and smaller objects. We shouldn't see things pop out of into existence out of nothingness and then disappear and then come right back
Unless that's
at
the
a
way
zero energy level.
unless that's the way it's designed to happen.
That's just the way it's designed. You know what? One of the things that gets me the most, and we talked about this, the things that get me when I talk about the double slit experiment and the breakdown of some of the physical properties of physics, for lack of a better term.
Or reality.
Yeah. The other thing that really bothers me the most is when you look at the way things are created, and you can go back and you can say,
What are we talking about? What things are created?
well, I'll clarify.
Okay.
You go back and you can say where Thomas says that there's a creator that made us,
Okay.
or that things exist. We look at like the Fibonacci sequence is something that's always bothered me. You have a golden ratio which comes out of the Fibonacci sequence.
Yes.
And you have
Think of snail's shell.
you have elements of mathematical computations that occur in almost everything that exists. And you can say, well, a tree doesn't have any elements of the Fibonacci sequence or the golden ratio.
It
Well,
does.
Yes, well, hold on.
Okay.
Let me clarify.
All right. Sorry.
Yes, it does.
I didn't
When you
say
get
that,
down
Scott
to
did.
the fundamental level, when you get down to DNA, the DNA out of a tree does have that. It absolutely does have a golden ratio. The helix, the double helix does. So, I mean, when you start looking at things that exist in life, biologically, those two things kind of factor in heavily into creation.
Does it? When you say factor into creation, are you saying that they are a property of creation? Because obviously that's the case, or are you saying that creation couldn't exist without them?
I'm saying that they factor in. If it was created, it's kind of odd that you would have these things fall into place in so many areas of life.
I
What
think
do
if
you
you go back
Or
even
sorry.
into the word creation, can you have something existing before creation, or is everything after a creation?
Are you asking Travis?
No, I'm asking both of you because
Okay.
a minute ago,
I think we can, if any time that you conject or hypothesize of something that was before creation, we have no way of determining
So-
any part of
right,
it.
so we
'Cause
have
it's
to throw-
outside our bubble of reality.
right? So, I guess the word creation can only let me make sure I say this right. Can the word creation only exist from a biblical standpoint? Because
No.
to create
Yeah, I don't think so either.
in what we're talking about, maybe our concepts, to create out of nothing,
Thomas, the thing that gets me when you talk about the Fibonacci sequence,
right?
You say you see it so much. Well,
Travis has a back piece of the Fibonacci sequence.
what?
A back piece tattoo.
Oh yeah, I got it. Because
The way his hairs grow on his chest,
it's a Fibonacci sequence,
it is.
or
It's
is
beautiful.
or is it a golden ratio?
Yeah.
I'm double fisted here.
Yeah. Well, I mean, it's like, okay, for everybody that don't know, the Fibonacci sequence is a series of numbers, and Scott could probably explain it a lot better than me.
You're fine.
But you go every number is added to the last number. And you go 1, isn't it?
1,
1, 2, and then
3,
it's 3.
5,
And then it's
8,
you add the last number to the next
11.
one.
The last two.
Yeah.
Not
So
10.
it's 5, it's 8, it's 13.
Yes.
And
You're doing
and
great.
it goes on
Yes.
perpetually like that.
Ad infinitum.
You know, so when you draw a
7.
picture of a man, we got 2 eyes, 1 nose, 1 mouth, 5 fingers, 5 toes, 2 legs. They all fall into the Fibonacci sequence, and you find that in nature. And the golden ratio is an aspect of the Fibonacci sequence.
Absolutely.
And you find it throughout everything that's almost alive. There's very few things that it don't fall into in some manner. And it kind of leads you to the idea that there's no way that these things weren't created or made by somebody.
Intelligent design is what you're referring to.
Intelligent design. It doesn't just happen randomly.
Unless
Does
it's
it happen
unless it's
randomly?
in a simulation. The simulation is like render everything like this.
Right.
Render like
Because
this.
it works.
Because it works. Render it like this. Render it like this.
Thomas, exactly.
Or
There's another aspect. Go ahead, Thomas.
it's the grand design.
That's
Right,
another
from the
that's
grand
another
creator.
possibility, which
the
is
grand
entirely
design.
as likely as everything else that we've conjectured.
Right.
Or there's another possibility.
What is it?
That is, if you have an infinite number of universes, it stands to reason that in one of those, just by pure random, that would happen.
So it's only happening here.
That you can't argue that point.
I can't.
That's my point.
I've never even thought of that.
Are you serious?
or it's happening just like this, and they call it something else.
Well,
You just blew my mind. I'm done.
Yeah, that was awesome.
well, what I'm saying is, yes, no matter how unlikely something is to happen, with an infinite number of chances, it's 100% going to happen.
Right.
You right? Okay.
100% agree.
Yeah, well, and so that's just another aspect. Now, still, we don't know which is real, which is not, but it's a possibility that we can't discount.
We don't have another ecosystem to compare it to even say that. But
No.
No, we don't. But again, it's supported by science and this expansionary cosmological theory, which I have been telling you about recently.
evolutionary theory?
Expansionary.
Oh,
yeah,
okay.
expansionary. Yes, cosmological expansionary theory about that just keeps popping off these bubble universes, and of which ours is one. Out of enough times, then things are going to work out where it works for us. There may be an infinite number. See, that's what's strange about infinity. You think about this too, guys. You can think about infinity just for a second. You can't really even ponder. Sure, you could say, okay, infinity goes on forever, but really, what does that mean exactly? That it goes on forever? Think about that.
Because
Okay,
it had to begin sometime.
well, or it didn't. See,
Or
that's
it
a whole.
didn't.
Yeah. Okay. Okay. Imagine yourself standing on a small moon. So I say it's about the size of a Volkswagen. So you're standing at a pretty small rock of space, and let's say for some reason, you could breathe. Above you, below you, beside you, left, right, front, back of you is an infinite amount of space. It doesn't matter how far you travel, how fast you travel. Let's say you could go.
how fast you
Let's say you could go 1 billion times the speed of light. You could travel.
But we know you can't.
I'm just for the sake of argument for this. I'm talking. We're trying to let them
trying
conceptualize
not to
infinity.
argue.
But we know you can't.
Let's say you could go 1 billion times the speed of light for 1 billion years. How much closer to the edge of infinity would you be at the end of that billion years than you were when you started?
It's almost like you just started.
You'd be no closer.
Right.
You would never. So
if time was a year,
yes,
right?
right. So you would
And-
be no closer to the edge
Yeah.
of infinity than when you would when you
Yeah,
started.
you're still in the very first second.
That's right.
If time was a year.
Exactly. So
You're in
the only
first
argument, the only argument I would have, to
And
what
you would
just
you'd be in the
said,
first millisecond.
is that when you look out into space and you look at a galaxy, most galaxies have aspects of a Fibonacci sequence.
yeah, but I wasn't. I was trying to let them conceptualize infinity.
I understand,
not-
but I'm just thinking
because we think the edge of our universe. We think there is an edge of our universe. That's
Sure
the
we
point.
do.
Yeah.
But
The static from
but
the
there's
radio
something
trans-
outside of that.
Got to be. Because
Yeah.
you can't have nothing.
Yeah, well, or can you?
I say no.
Well, according to the Planck space, we can't have nothing.
That's what
You
I'm
know, But again, all
But
that.
according to the Planck space, we do.
Well, again, the Planck space is within our universe, right?
It's within our
Now,
understanding.
we don't know how it would behave outside of our universe.
Oh, wonderful.
That's right. So
And what's our understanding going to be like outside our universe?
we have no.
'Cause, again,
no comprehension.
We barely have comprehension now.
That's right.
Because it's so
This new
crazy.
theory about this cosmological expansionary theory is that outside of our universe, supposedly, is an infinitely expanding, infinitely energetic quantum waveform, which is spawning off baby universes as it goes.
Right, one theory. Right.
That's a theory. That's exactly right. Yes. Now, is God that quantum wave function? Absolutely could be. I mean,
Why not?
why not? Exactly. And then, if indeed that's the case, then yes, the Fibonacci sequence, which you're so enamored with, that was a function of his thoughts for that. I don't know the mind of God. I'm not ever pertaining
Well,
to.
maybe,
Right.
maybe that's the only thing that worked.
Well,
It works great.
it might be the only thing that works in our universe, but every other universe could have a completely different law.
Maybe it's the only thing that
laws of
worked.
physics.
Maybe it's the only thing that worked anywhere.
We'd never know. We'd never know.
We can't know.
So, is the universe real, Thomas? What do you think? And tell me why you think the way you do. And what does it mean to you?
Let's see. So it means everything for me to say the universe is real.
Okay.
And
what's a product of that for you personally?
Love.
Okay.
I think the way I feel about people, the way I love my wife, to me that is real. If that love is real, I think the whole universe is real.
Okay.
I think just the fact that I can feel, I can, just,
You can hurt.
I can hurt. I think the way that my body is made in my simulation
And your mind.
in my mind, I think it is absolutely 100% real.
Okay. All right. Thank you very much.
You're
What
welcome
if you
very
were given
much.
proof that it were not? Then how would you feel?
Oh, then,
What
then
if-
everything is off limits, right?
Well-
if nothing is real, nothing
I mean,
matters.
what if the CERN scientists came out and they said the newest experiment at the Large Hadron Collider or its predecessor came out and they said we can absolutely determine that the universe is a simulation? How would that affect you personally?
So I guess I have to say, what's the point of announcing that? Everything
science
is
has to
everything is
progress.
crashing at that point, right? So if the universe is not real, then nothing matters anymore.
Well, okay. When I say
if it's
when I say not real, the simulation is real. Okay,
Right, yeah.
and our existence within it is real. In other words,
right, we made it to the edge of the video game cartridge.
yes.
And we say, oh, we've been
You're showing your age, by the way, by
I
saying
know.
cartridge.
cartridge. We just made it to the edge of the cartridge.
Okay.
We see what's controlling us
Okay.
now.
Right.
This is all fake, and we can prove it.
So how does right? How does
Nothing matters anymore.
you would quit loving your wife?
No, I would still love her, but
Well, that would matter. So how would it affect? How would your existence within it change if that was hard knowledge?
so I would start trying to define the laws of physics. Just if everything's a simulation,
Mm-hmm.
I'm going to go against the simulation. I'm going to try to fly. I'm going to try to walk on water. I'm going to try to do all this stuff that
You're
you
going to
say.
try to become Neo.
Yeah, try to be Neo.
Okay.
Absolutely.
I can understand that.
Yeah.
Very good thing. Okay, Travis.
Hey.
Same questions to you.
You can't beat it. You can't.
Listen, what was it?
You
Okay,
can't
that's
say
all.
be like Neo.
Okay. All right. What I'm saying is,
Yeah, I got that one.
yeah,
You have to come up with something on your
what
own.
do you personally think about the universe? Is it real or is it not? And let's say, for sake of argument, that it is real. And or you tell me what you believe. Is it real or is it not?
You know, I honestly don't know,
Well, I mean,
and I don't think that
you don't have a
the
feeling.
the fact that I exist at all kind of leads me to believe that it is real. I know that we all experience the world, and our experience is unique, but the reactions of the people around me tell me that those people are not unsimilar to myself, and it kind of leads me to believe that there has to be some kind of substantiated reality to it.
But at the same time, you can't prove that your house is still there right now until
Thomas,
you get there.
I think that we're here, and we're a cosmological wonder. I think we're stardust looking back at the cosmos. I think we're the first element of the universe that we know of that experiences itself.
That's almost a quote from Carl Sagan. Carl Sagan says that we are the cosmos looking back and questioning ourselves.
I think so.
That's or something.
And I'm
wasn't
not trying to
verbatim.
say
It's
I'm
paraphrased.
not trying to say I'm him.
No, I understand.
Because
Travis Stardust
brilliant,
over
and
there.
I've never read that, but I
haven't
really believe that, and I think that I think there's a lot of stuff that's questionable, but I don't have the answers to it, and I'm not smart enough to really contemplate the.
But you're
answers
smart
to
enough
it.
to ponder
I ponder
the question.
I do it all the time.
Sure, I know you do. Let me ask you this. Okay, so you're saying then, although you can't definitively say, as none of us can, that the universe is real or not,
Yeah.
you're saying that your personal feeling is that it is real.
I think so.
Okay, and you base that on what you just said. Okay,
Yeah.
I'll give you the same question I gave Thomas. If the CERN scientists or somewhere in the world, a scientific team came out and they absolutely proved and showed us all in
That it
in
wasn't?
proof
It was a
that it was a
simulation?
simulation. How would that change your life?
Well, I would pose another question to you. Can I unplug myself like Neo did or not?
Well, we don't know the answer to that. But what I'm saying
Because
is,
if I can't unplug myself, it doesn't change anything.
okay. So what
I
you're
live
saying,
my life like I live it.
there you go. And see, I completely understand that as well.
So then CERN is saying, hey, this is a simulation, right? And now you understand that. And now rules, regulations, nothing matters.
Well, no, let me clarify that. They're not saying what they're saying is everything that's happened, everything that is fake. Okay,
Right.
But they're not saying that if you drive your car 100 miles an hour into a tree that you're not going to smash and your part of the simulation will be over. They're not saying that. They're
Right.
simply saying that everything that we see is not real.
Right. But what does it matter to somebody?
If they do die, because they're not dead.
Doesn't
Right.
matter.
They're not dead. Right. So
Yeah,
what
does
does
that
it matter
Answer
if...
your own question, Scott.
I will tell you. Okay.
Yes,
All
let's
right.
hear it.
Okay.
CERN has just discovered that
Well,
the
first of all, I'll
simul-
say if I think it's real or not.
No, no,
Okay.
no, no.
Personally.
I was wanting
I-
to skip it.
I personally think that that it's all a simulation. I
Right.
do. Now, again, I have no proof of that, obviously. Now, does that change the way I feel about my friends
To
and
the
family?
simulation.
No.
No. My love for them is as genuine as anything I think can
Well,
be.
from a simulated family member, I appreciate that.
That's you're
You know what
welcome.
It reminds me of. It reminds me of a Star Trek episode with.
Okay.
You know the one where
The guy in the uniform.
Hold on. Star Trek episode, and do I know the one? What's the answer to that?
He's in the uniform with the thing.
come on.
If it's a
Tell
Star,
me, Captain.
you're talking about Captain Picard,
Picard.
and it's the name of the episode is The Inner Light, where he
Yes.
perceived his entire life on the whole
Oh,
planet.
exactly, dude. Exactly.
Don't
I
make
know how
me
you
cry.
Yes,
I don't want to
okay.
cry.
No, tell
Don't make me cry.
No, why? Why would you cry?
I love that episode, man.
It's my favorite
it's a
episode.
great episode.
It's my favorite episode.
It's broken my heart
Right,
so many
but
times.
Picard lived his whole life there.
Yes.
He did what. But anyway,
He
go
raised
ahead.
children.
Yeah, go ahead with your answer.
And he thinks about them all the time because he spent 40 years with them.
Yeah.
Yeah, or about close to about 45. Yeah, 45, 50 years. Yeah. Okay. Yes, it doesn't change.
Stewart.
The love I have for my family members, all of them, and it wouldn't change. I mean, because if everything I see, and even this concrete knowledge that it doesn't exist, I don't exist either. So how is me feeling the same way I do going to change anything? I would do just like you said, Travis. I would continue being anything that I could be. But I think I would also bring an aspect of what Thomas ought into it. I think knowing that the universe was actually fake, I think I would try to bend the rules.
You're right. How do I get into that program?
How do I
write this
hack
in?
the universe?
Yeah.
Right?
Yeah.
That's what we're talking about. Because it would be great. Oh, I'd have a lot of women. There'd be a lot of women in Scotty's hacking.
There'd be a lot of disappointed women.
You know, I've often
Simulated disappointment. It would only be simulated. Their disappointment would only be simulated. So it wouldn't matter.
How do I overwrite that? How do I overwrite
simulated disappointment feels better.
that?
It doesn't matter as much.
It's not real disappointment.
That's right. Okay. So that is funny because that's exactly right. But that's
But you know
that's
what?
how
You
it
know what
feels.
blows my mind? The Picard episode where he does that. What
Yeah.
was it again?
The Inner Light.
The Inner
Inner
Light.
Light.
It's a Star Trek: The Next Generation episode.
He's
Oh,
on
it's a
he's on
great
the planet
episode.
Catan.
It's my favorite.
We're not trying to
my
promote
favorite.
Star Trek.
Absolutely,
You don't have
we
to.
are.
It stands on its own.
It
Right.
does.
But I mean, we can.
Next Generation is the best. Anyway, it doesn't matter. If you look at that and you think about that, I kind of wonder if the writers that created the episode, they weren't kind of trying to say the same thing. You know, are we living in a simulated world?
And maybe that's where they got the
The
Matrix
best storytellers, hold up mirrors to reality. Reality? Whoa.
Bum, bum,
Nothing is real. Okay, so that's my thought. I don't think it is real. I'd be more than happy to be wrong. But I think that looking at what science is doing now, examining those spaces that are smaller than the small, and seeing the fabric of the universe as we know it break down by the wave functions and stuff that we're detecting, I don't think in a real tangible universe that could happen. Now, I could be wrong, obviously, because that might be reality. Just like I'm saying, my hand, the table, the glasses, the liquor that we're drinking, it all seems tangible, but there's more empty space in this glass than there is solid.
without a
the
doubt,
space between the atoms. Just to let you guys know, in any object, guys.
Which was a great movie, Inner Space. I loved it.
Meg Ryan was so hot in those days.
I know.
But anyway, there's more space in the space between the atoms proportionally than there are the stars in the galaxy.
That's absolutely true.
And it's crazy to think about that because you can click these together, but yet there's more empty space than there are solid. It's crazy. I have no more final thoughts, guys.
Oh, I don't know.
I mean, this is an open-ended discussion, obviously. Please,
Yeah, it is.
Please comment. Tell us what you guys think. Please give us comments. Tell us what you think about the universe. And if you're a scientist out there, tell us everything that we've gotten wrong.
Yeah.
Please, we will give you your credit, and we'll put an addendum out. I promise you.
Break it
Yeah.
down into paragraphs, not
Yeah.
essays.
And draw some pretty pictures so that I can understand.
You've heard of shade tree mechanics. Well, we're shade tree scientists
No.
and theorists. So we're more than happy to be corrected anytime.
Anytime.
Yes.
Yeah,
But
true.
what we do want to hear most of all is tell us what you guys think seriously, and tell us what topics you guys would like to have us tackle.
Right.
We'd really love to hear from you
We
guys.
could do this one again, actually.
Oh my God! This is
We could do
scratching
this
the
one
right.
16
I
times.
would say scratching the surface if it had a surface.
If it had a surface. Goes back to my point. Our knowledge is limited, both expansively and deductively, going all the way down,
That's right.
dividing it
Absolutely. Travis, you have anything to say?
I'm pretty empty.
Well, you are mostly empty space, even though I can feel you. That's right.
down. Way to tie it in.
Okay. So anything, any shout outs you want to give to anyone?
No, not really.
Okay.
I just want to
Yeah,
apologize.
Tony.
I have to apologize to Tony again. This was not my fault. I wanted to do this a long time ago.
Oh, and to Steve. I want to tell Steve, I
Yes.
wore the T-shirt,
Love the
but
T-shirts.
never on the podcast, and I apologize for that. I apologize.
Give us you're going to wear it next time. Is that right?
Next time I'm on, I will wear it.
All right. We heard that.
Because I've been
I heard-
ridiculed for not wearing it this time.
At least once today.
I didn't want to be a follower.
You're not a follower. You're a
Promoter.
presenter. You're a promoter.
Okay.
Yeah, you're a promoter. Promoter for this right here.
Right there.
Yes.
So there we are.
We love you guys. Thank you for spending your time watching this craziness.
Yeah, you didn't have to, but you did,
But
and
you
we
did
appreciate it.
and you know what? We're very, very happy and very, very much indebted to you for doing so.
Yeah.
Thomas, any final words?
I don't think so. I mean, I can't
I
wait
wanna
till
give a
the
shout
next
out to your
one.
wife for sparing you for tonight.
Yeah, she's pretty.
Thank you,
awesome.
Rachel, for loaning Thomas to us tonight.
She's incredible.
Whether she's real or not.
She's very
Incredible.
patient, whether she's real or not. I hope she's there when I get home.
I think she's a simulation.
She's got to be. She's-
Okay. Would you say something else, Thomas? I'm sorry.
She's got to be. I mean, her patience knows no bounds.
Leads me toward simulation.
It's
theory.
got to be a simulation.
Yeah, because in reality, why would she be attracted to
Oh,
I
that's
know.
my thought exactly.
Yeah, it's like, who
my
wrote
thought.
that code? Thank you.
Love you guys. Hope to see you back next time on episode 8
8.
of How Do We Get Here podcast.
Yes.
So we glad you joined us for the How Do We Get Here? Is the universe real or not? And what does that mean to you guys? Thank you for coming and joining us. And until next time, the How Do We Get Here podcast crew is out.